Hello everyone, I am Rahul Gupta again with a new concept in Swift which is call by value and call by reference. So let's start our session. In this video, we will cover the difference between call by value and call by reference, implementation of call by value in Swift and implementation of call by reference in Swift with live example. So let's start the session. First thing is call by value versus call by reference. So the functions can be invoked into two ways. First is call by value and second one is call by reference. Call by value. In this method, value of actual parameters are copied into function's formal parameter and the two types of parameters are stored in different memory location. So any changes made inside the function are not reflected in actual parameters of the caller. Call by reference. Both the actual and formal parameters refers to the same location. So any changes made inside the function are actually reflected in the actual parameter of the caller. So we will discuss both style one by one with live code example very shortly in this session. In so call by value in Swift, we can categorize data into Swift into two types. First is value type and second one is reference type. A value type instance keep a unique copy of its data, for example a structure or a enum. So since see in Swift the value type is a category of data which does not share a value, right? When you will try to share a value, it share a new copy, right? So let me explain this concept with the help of code. So as you can see here, I created a value type that is called structure. See, let me change this to struct. So as you can see here, I have created a value type that is called struct as a user with parameter first name and last name. So let me run this code. Okay, so you can see the output here. So as you can see here, I when I modified the first name and last name in user2, the user1 still have the old data for those properties, right? Since when I try to assign the instance of user1 to variable user2 in line number 14, so sorry, in line number 15, so it creates a separate copy and then assign to user2, and so that's why when I change the properties of user2, so user1 is unaffected. So let me go back to our ppt. A reference type shares a single copy of its data, and the type is usually a class, right? So let me go back to the code to explain this concept. To explain this concept, let me change our structure to class, right? And then let me run this code. See, now we have changed the user from value type to reference type. So and now you can see the output. So you can see I just applied the changes in user2 properties, but we can see those changes in user1 properties also here. When I try to print the properties of user1 and user2, so the value of both user1 and user2 is same as the latest changes, right? So let me go back to the slide. since a value type always share a separate copy of its data, so when we are passing any value type in a function, Swift create a separate immutable copy, so doing changes directly to that is not possible by the function. We can say it is call by value. Since reference type always share a single copy, we can't achieve call by value by passing reference type in the function. Just a minute. Let me explain this concept with the help of another example. And here is the example. Let me change this from class to structure, and then yeah. So as you can see here, if user is struct type, so my function is giving error and saying the value type is immutable. What is this error want to say? That my value in my user value is immutable. This value type is immutable. User is immutable parameter. So in order to do any change, we need to create a new copy of it, and then we can apply the changes on that copy. So definitely, if I will follow that approach, so that change will not remain with globally. That change will remain only within the scope of the current block. So it is not called by, we cannot say that it is called by reference. We can say this approach is called by value. So because the scope of that change will not reflected to everywhere, right? So but now let's change it to class again, and then you can see you can see uh, when we are trying to apply the changes in the property value, it is not giving any error. My Swift compiler is not giving any error within that function, right? So now let's run this code. Yeah, as you can see here, we can say that the new changes is applied in the global scope. What the changes we made within the function, and after this after calling this function, when I want to when I want to read the property, so the value of the property is as per the new changes. So we can say this that change is applicable in global scope of the file. So we can say this approach is called by reference. Now again call by reference. So we can implement call by reference in reference type and value type both. As you or as in last slide I said that we can't apply value type in reference type. So means we can't apply the call by reference call by value to reference type, but the call by reference we can apply to reference type and value type both. So when we pass reference type in a function, it just share a reference instead of the copy. So when your function will do any modification in that, it will reflect anywhere outside of the code also. As I say, I already showed the example of this concept in my code, right? So hence we can say that the passing a reference type is always a call by references type. As I already explained, generally when you pass a value type, Swift create a separate immutable copy and function cannot modify it. So when in that function we want to do any change on that data, we need to create a new copy. But Swift allows us to implement call by reference in value type too. How? So for this, it introduced new keyword called Inout. So Inout allows us to change the variable passed in because it shares the instance of parameter instead of copying the value denoted by the preceding ampersand. Let me share the example, and then I will describe these two concept, these two lines there with the code. Here you can see this is the structure, and like in this code you can see here I I called the same function change props, and I am directly applying the changes into the structure parameter, that is value type. Here you can see the structure is since the structure is value type, and I can apply directly the changes on that property, right? And I am not the Swift compiler is not giving any error because I am using inout as a keyword. So when I added inout, it's what inout do. Inout creates actual, then inout shares the actual reference with means we can say that the reference of user. Now here the this variable user and this variable user is user one, and this variable user are trying to access the same reference. Because inout shares the same reference, it is not creating another immutable reference, right? Another immutable reference is not creating by inout. So that's why when let me run this code. As you can see here, after calling this change props here, what the modification we did within the function, we can read that modified property, we can access that modified value outside of the function after calling this, right? Now I have changed first name and last name to QWERTY, and when I am trying to access that from outside of the function, the property name is QWERTY and QWERTY, right? But the thing is that let me do a new let me do some experiment here. I am trying to read those properties from user 2. Let's see what is happening. See, that change is not applied to user 2 because user 1 and user 2 are the two separate copies. And what we are doing, we are passing user 1 here. When we are passing user 1 here, so what inout is doing, inout is just inout allowed me to share the copy between user 1, no, not copy, share the reference between user 1 and this variable user. But still the user 1 and user 2 are pointing to different copy of this user structure. So that's why the that change is not reflected to user 1. So it is supported by reference type also. So if you are using inout with a reference type passing argument, Swift compiler will not give any error. But since passing direct reference is also we can say that it as this approach is also called by reference style, so it is worthless to use inout data for that. So that's all for now. In the next session we will bring another concept of Swift. Till now, thank you.